Let's look at chapter 3. I believe we've got it for the next 2 weeks. Yeah. So let's look over concepts today. And then Wednesday, let's go in and look at it in terms of logarithm on it.
Are you going to be here Wednesday?
I'll be here Wednesday.
I thought y'all had a meeting in Macon.
No,
It's
that's on Thursday.
It's on Thursday.
Well, I don't know, either you or Mr. Spurlock has some confused because he said it was Wednesday.
Yeah.
No. He's going to head out earlier to go to Macon than I'm going to head out.
Okay.
Okay?
He said it was Wednesday, didn't
Yeah.
So he said he wasn't going to do classes Wednesday.
he?
Okay? It's going to be that evening probably before I get away. I'm hoping to leave right after y'all's class, but I may be later. I'm not sure. But the meeting is on Thursday. Okay? And then Friday I won't be at the school because I'm going to stay in South Georgia. And he's going to be probably at one of the campuses Friday. Usually on Walker, so.
What page is this on?
81. They throw this chapter in this book much earlier than most books do. So I wouldn't put it till later, really. But they've introduced it in chapter 3. What they're doing is we're going to use modules. And what you're doing is you're taking a larger program and breaking it up into parts. So that you've got a part that does some specific task, another part does another task, another one that does another task. And you've still got your main program there, but it's just calling these others to do the different things. And so you've split the stuff out into the areas of where it is. The programs you've done so far, the flowcharts you've done so far, have been simple ones. And actually, if you tried to modularize them, you're going to be going, wait a minute, we got to do more work to modularize it than if we leave it as is. But the idea in breaking it into modules is that then it will be easy to find the section that does some type of part of the work. Instead of it being one giant fall down through program, to have it in smaller pieces. So their illustration on page 83 would be an example of that. Okay? So instead of that whole long list of statements, to have them in separate things. So that they said a payroll program, that they could break that into modules. That one module gets the employee's hourly pay rate, a module gets their hours worked, a module calculates their gross pay, a module calculates the overtime pay, a module calculates the withholdings for taxes and benefits, a module calculates the net pay, and a module prints the paycheck. To me, that one is over modularized. Okay? Their first 3 modules there, or the first 2 modules there, I would make that one module. A module that just gets the information about the employee. The second 2 modules they've got there that you may well make them a single module also that just calculates the gross pay, whether it's overtime or no overtime. And then a module that calculates the withholdings, that a lot of people would split out into a module anyway, because think about some payrolls, you've got a bunch of different things that could be withheld on a person. And so you could have a number of things, and to separate them out to be able to keep up with that, and that changes quite regularly. And you might have a module that does the printing. But quite often that modules, when you get to larger programs, you're looking at modules having a number of lines in them, but the object is to keep it down, broken, easier to find. That student records program that I've mentioned to you all already, that I wrote, that had 300,000 lines of code in it, I had it modularized so that I had financial aid in one section, printing a transcript was a separate section, printing grade reports was a separate section, entering grades was another section, entering basic information on students was another one, printing lists of students according to their classes was another section, and there was about 24, there was somewhere 20 or so major modules I had in it, and then I broke modules apart, but I had things split out according to where the related type things that fit into an area. Big part of it is the idea is that it is going to be easier to understand, because again, it's not one long thing that you got to hunt straight down through it, but you just jump to the correct module and look at that code. So for maintenance purposes, it would work nicely. And that's where your big concern is in terms of making them easier to read, is in terms of maintenance. And programs have to have maintenance to them. One, you find out there's errors in them later on. Things change. It's like their payroll program they just mentioned up there. All of those withholdings would change continuously. How you pay overtime pay could change. Code reuse. If you do it in the modules, you can actually use modules that are called by different programs. So you can have a module out there that's used by several different programs instead of having to write the same code again and again. Then it comes back to the testing of it, that you can test the things down to the module, and you know where you're looking for the error on it, that you're not looking through this whole big thing. So that when my student records program had a problem with it, I knew what section to go look for in it. That I didn't have to look through the whole thing. I knew which module to go look in depending on what it was doing wrong. Maintenance I already mentioned to you. And modularizing it may make it easier in terms of fastering your development, because you've reused parts from other programs that you already wrote something and you pulled that module into it. And to work a team together, if a team was working on something, you can make an easy way for splitting things up between the different ones, so that I could give him one part of it to write on, module to write on it, you a separate module, you another module, and you another module, and me write the part that links to all of the modules, and then they could all sit along separately and that you could work them. But yet we're working as a team, doing the approach on it. So you can use modules in a number of ways. You're going to name the module. You have to name them. Generally, what you want to use as a name on it is to put in the name what it's doing. So what's that module do? So mine that handled the financial aid stuff for the college, I called it, I think, financial aid. If it was a section to print a transcript, it was print transcript. Or it's either print transcript or it may have just been transcript. And actually had some other code in front of it in the name that told me about how it all fit together. With the module, you're basically, what you wrote in the first 2 chapters, you wrote a single module program, okay? With a multiple module program, they're going to look similar in your flow chart, so that you had that to start with some code in between. Now you're going to have others of them, and you're going to have some spot in here with a box where it gets to the point where it needs whatever's over here, that here is going to call, do they do call or what? Yep, call. And whatever the module name that's here. Okay? And what happens is as it comes through this one, and this is main, but you may also see a start right there. Name here's got to match name here. Now, after that name, there's going to be a set of parentheses. For the moment, we're not going to have anything in the parentheses because we're not passing anything. It's then going to come through here, and this is not going to be a stop or end. Same shaped box we had before. It's going to be a return. What happens is, when that occurs, it comes back to right after that call box. Y'all follow on that? Y'all see how the logic is? Now, you can have modules call modules also, and they just work the same way. Guess that's right.
Yeah, right now.
Hmm?
That hard right here.
Was a few minutes ago. Yep, that's right. But when you call it, it comes over here, does whatever's here, and then does a return. Okay? Now, they're separate. Variables in here are different than the variables here. So you can have the same name here, and it's actually a different variable. So we've got variable A over here that we declare A. We can declare A here also. This is a different A than this A. Y'all follow on that? Y'all see how that's working? So the variables are local. Now, it is possible outside of this whole thing to declare a variable. And I've got to look and see how you do, if you can do that. In Logarithm, you should be able to, but I'll have to look at it. That would be a variable that applies to this whole thing, which is a global variable. So this one's global. Okay, it applies to all parts of that program. So if we say anything about B in here or B in here, it's talking about the same variable. But if we say something about A in here, it's got nothing to do with this A. Those variables are local on it. Okay, so the object of the module is to break it down in smaller parts. Now, if you think about that example problem they gave you, of their example of breaking it up there on page 82, you've got to pass information back and forth between them. Because if your module here is inputting hours, and then there's another module down here that calculates hour, that calculates pay, equal to hours times something. We got to get the hours from here down to here, right? Y'all follow on that? But in this case, we've got another call. We got to get the hours to here. Okay? Now, in Logarithm, and what I was told in the past has not done some of this real well. So I intend to play with it, but I just haven't gotten a chance to play with it. But I'm going to try to do that tonight. Go in and do some modularizing in it and see how it works, and see if there's something I need to tell you special about how to do modules. There's a reason for waiting to demonstrate algorithm to you till Wednesday. And tomorrow makes a good day for me to check on that stuff too. I only got the one class tomorrow. In the parentheses after that, we can pass values to the other one. So we'll be able to pass a value across, but we're really not passing the variable across. So if we say call and have A here, it's going to pass it to here where it's going to be a parentheses also. It's going to pass the value of A over to here. Now it's not going to pass A over. Y'all follow on that? Whatever variable we list here, say B, well let's not say B, say C. Whatever value A had at this point, A will still have, but C and this module will have that same value. Y'all follow on that? Now, quite often, and what people generally try to do, but if you're using modules, this doesn't always work. That you'll just try to use the same name in both places, and then it keeps things away from you. But in the process, when it gets here, you've got to declare it actually up here where when it comes in, because it is a new variable right there. So you're declaring it for that module. So you're going to call it by saying call and the name of the module and parentheses. And if you've got any values to pass over to it, you will put them inside the parentheses. It could be a literal number or word, in quotes, or it can be a variable name there. It's the value is what's getting passed. So you could actually put a number there that you're passing over that it then puts in a variable over on the other end. Okay? Now, the types have to match. So whatever type this variable is here has to be the same type variable as this one here. So here on the start of it, you'll actually do a declare right there, and you got to declare it to the same type as, in this case, C's got to be declared to the same type as A was declared over here. You can't pass a real number here to an integer over here. Okay? It will give you an error for that. So you'll go, can't do that. You can't change types in the transfer. Okay? Now, if you do need to switch types, you can get away with that within your module of, say that some variable, you could say a real variable is equal to an integer variable, and it will take that integer value and put it into the other. Likewise, you can say an integer variable is equal to a real variable, and it will truncate it when it puts it in there and just drop everything after a decimal point and put just the whole portion of it in. So you can get it into the other type, but you can't do it across on a call. So if that's your problem, if you need it in the other type in that module, because the module was written using one type and you've got it as another type, you can change it and then do your call using the changed one. And there's actually functions that will work for us on there to do it very specifically. So when it reaches the end of the module, which could be end module or return, I'm putting return up there because that's the way I always learned it. They've got end module that they're doing in the book on it. It comes back to immediately after the call box. So it goes to the next box in line. But it returns it to after the call box. Does that make sense? So it drops it in right there and then continues on. Because their comment is it returns it to the next box. Well, it's really not returning to this box. It's really returning to just before the box and dropping whatever into that box. So it's sort of like this whole thing right here. It's all drawn in right there in place of that call box. Just picture it drawn back over in place of the call box. And that just goes back to the top-down design, which is what we've seen along the way, and that's just saying things work from the top down. And that's the design we've been using. They say it's also sometimes called stepwise refinement. I've never seen that term before. So I'm not sure where that is. A hierarchy chart shows us how modules are related to modules. So in this case, if this is our main, let's say this was mod 1 and this was mod 2. Hierarchy chart will show us the main module at the top of the chart, and then it'll show us all of the modules that it calls drawn underneath on the same line. So in our case, it's only got 2 modules there, so it's got a module called mod 1 and a module called mod 2. So none of that exists. And this is main. So there's the hierarchy chart for my program on the board. Now, it's using the processing box. It's just using that square rectangle, okay? But it's really not, these are not in terms, this is just showing how that all relates. So it's not, it's just using the square rectangle boxes is all it's using. They're not really meaningful shape to mean something in there. They're just showing how do these modules. So if module 1 called some other modules, they'd be drawn underneath it. You could have a module there that was called by both of these. Okay? Not likely, but you could. A module could be called by different modules. Okay? Which would be a reason for modularizing your program. Instead of having to write that same code that was right down here, instead of having to write a section here and write one here, you're reusing your module. Y'all follow on that? So you can, but for your purposes in here, you're really not going to fool with that. They're going to stay pretty much separate and drawing separately, and it can modularize on down lots of levels. Questions on that? On how that is working? Okay, they talk about the local variables. Like I say, variables only apply within the module they're declared in. They don't work elsewhere, so they're local to the module. Unless we make them global, which we can do up at the very beginning. In Java, you put global before the name of them, and that says they apply everywhere. And actually it sits into here, but they're declared right at the beginning of it, and it's declared as global, which means they belong everywhere. Because you could have something you want to use everywhere, that name, and for it to be consistent. And then the value passes back and forth automatically for you. You don't have to pass the value back and forth on a global variable. Local one, it only works in whichever module. And if you want, you will have to literally pass it through your call statement or your return statement to get the value switched back around. But it could be another variable name that it goes back to or comes going to. So that's the scope, is where does it apply to? Does it apply just in a module? Or does it apply across all the modules? If it just applies in a single module, it's a local variable. If it applies everywhere, it's global. Now, you can't do one that's going to apply in 2 modules, but not in 3 other modules. It applies to them also, if it's global. So it's either one module or everything. Everybody follow on that? So you don't get that choice on it. So, within a module, you can't have duplicate variable names. Okay? We can't have 2 different variable A's within this module. But there can be another variable A, like we've got drawn up here, in this module and this one. Which means within the program, as long as it's within modules, you can have duplicate variable names. They just got to be in separate modules. So you can't have duplicates within a module. Now, I said before, the programs you wrote in Chapter 1 and Chapter 2, they were modularized technically. They had one module. Okay? And since it was one module, you couldn't use duplicate names in there because you can't have duplicate names within a module. So your program couldn't have duplicate names, but when you go to multiple modules, you can have the same name used in several modules. Because that was the main module y'all wrote in Chapter 1 and Chapter 2. To pass stuff there, you'll do a call, in the call, inside parentheses afterwards, you'll list the variable or the values that you want to pass. And it can be a literal or it can be a variable. All it's going to do is pass the value either way. Okay? Does everybody follow on that? On the actual module over here, that there you will put the same thing. You will put what you're calling it across, and you will do an implicit declare. You will tell it there, so here we declared A as integer. And I guess those are probably backwards. It should be declare A integer, I think. Integer A. Whichever way it does, and that will be language specific anyway. So as long as we did declare A integer, meeting the syntax of the language. Over here, and we're passing A across, all we put is A here in the parentheses. On here, let's call this SEC. There's our module, the heading for it. And there, because we've made A integer, we'll do integer A. And what we've done is we've done an implicit declare statement right there. Does everybody follow on that? Because we've declared A as integer, and we said A here takes the value of A over here. So this would have worked just as well if this had been G. Then G would take the value of A. They're both integer. Because this A was declared as integer over here. And then we passed its value over, because somewhere along here we said A equals something. We passed that something over to here when we called SEC. SEC declared G as integer and brings the value in with it when the call was made. And so we've passed a value over to there. You can also pass multiple values. And all you're going to do is put commas to separate each of them. So in this case, maybe we got real H. And we're going to pass A and H over. Or A and, let's call it Q. Q over to G and H. You just separate them with commas. They've got to be in the same order. You decide the order you're going to put them in as a programmer. Okay? But you got to be consistent on both ends to get them to match correctly, because whatever's the first one here passes to the first one here. Second one here passes the second one there. And types have got to match. Is that making some sense to y'all? On how we're doing that? Now I say we'll go in and look at it in terms of logarithm Wednesday. So you can either pass them with the literal number or by the variable on it. And they talk about reference variables and the value. The reference one, they're saying it can change over there. If you declare it as reference, then what it's going to do is it's going to actually play it back. That it modifies that argument in the calling part. So if we did reference onto there on the module when we got it, we're saying pass that value back. But I don't think you're going to be able to do that in logarithm when I've been told, but we'll just have to try it and see. Global variables and constants, I've already told you about that one. You'll do that at the beginning before the main module. So it's in the program there, but before you to go and do module main, you'll make your declares, and that applies to everything. That you didn't do it inside the modules, you did it on the outside before you did a module. Now if you think about it, y'all actually had modules there from the beginning. How that's going to exactly work when we do logarithm, I've got to try that and see what it will let me do. All right, questions on that? Do y'all get the idea of how modules are going to work? And then I say Wednesday, and then we got next week too.
So we have 2 weeks for assignment?
Mm-hmm. Because 3 is not due until the 20th. Okay?
Okay with that.
Huh?
I want to say I'm okay with that. Don't block rushing.
Because we've got 11 chapters, I think it is, to do this semester. Chapters 1 through 10 and 14, if I remember right. And we got 15 weeks, so there was a few chapters I gave you 2 weeks on. Okay? And this happened to be one I gave you 2 weeks on. And I don't remember if I was even really looking at it when I think I was. That modules is a little bit different than what you've done. But yet modules is a way you've done stuff anyway. Okay? Because you really modularize your life anyway. We keep certain things at certain locations and do certain things certain ways. Okay? So, and that's the reason for we don't need to go through logarithm today on it. That we can wait and go through it and spend our time on Wednesday going through logarithm. And then we got next week to play with logarithm on it also. Okay? Questions? All right. The other three of you, are y'all following with what I've said?
Yeah, I mean, do I understand what you're saying? Yeah, but I like doing hands-on.
But until you get it hands-on, it's going to be better on it.
I mean, I'm not asking a lot of questions now, so don't like be off about that. I'll ask a lot of questions during the hands-on.
Mhm.
So I mean, don't feel off about us. Well, me, I'm not going to talk for this. Don't feel off about me not asking questions because I'll be asking them during the hands-on part.
But the concept of what a module is, y'all catch?
Yeah.
All of y'all catch that?
Yeah, it's
And
just, I need like to
You're just breaking it into pieces, okay?
Yeah.
Instead of the school here being all one big room, we've put up walls between the rooms and we've got stuff separated off in different areas,
Yeah.
Yeah.
okay? You modularize at your house. The bedroom's one room, the living room's another room, the kitchen's in another room. That it could be all one big room, and there's plenty of people in the world that live in a one-room house, okay? And that everything's all right there together. But we tend to modularize on it, okay?
Yeah, the thing is just we don't ask that many questions because we like need to start doing it. So
But the big part is, I just want to make sure you're getting the concept today, not the details. Don't worry about how we're carrying, exactly how we're carrying it across there. I'm just planting seeds on a few of those things. I just threw it at you right then while I was talking, like that they got to be the same type. Until we go to do it, you're not going to really catch that, okay? But I've thrown it at you, and now when we go to do it in the actual stuff, that you'll go, oh, okay. I remember he said something about that, and that we've got it on planted a seed there for you, although you may not fully catch the whole thing today on it. But the idea is that we can break the program into smaller parts, and then we just work with smaller parts all over the place. Okay? Questions? But we've actually just gone through the whole chapter. But we didn't go down into little tiny details on it. Because like I say, one thing is I've got to go into Fogarhythm and make sure how much of this will actually work. They don't get into in this chapter returning a value. But you actually need to be able to return values too. I'm not sure when they just toss that on in somewhere along the way. That the module's got to be able to pass information back. That they've got them. Input gross. Because they used reference variables to return on it. That will work in a few languages, but most of them, reference isn't going to really work for you. That's in specific languages of calling it a reference. Most of them, you got to give it a value to return as. That you got to tell it you're returning or make it a global variable. That they've chosen as reference as their way to pass it back. But I don't know if Flogarhythm is going to let us do that. I looked down at the book as I was getting ready to say Flogarhythm and saw global. All right, if there's not any other questions then, I will let y'all go early today, and it looks like we're not in the midst of one of our downpours at the moment. So y'all can sit here and work on some stuff if you want, or head on out, or whatever you want to do.